Good afternoon, everybody. My name is Evan Pasco, and today I'll be presenting for the B.R.E.D.J group on April 9th. So today I'll be covering tasks completed, tasks ahead, and some of our design evolution in relation to deliverable 8 modeling. So within the past week, we have completed deliverable 6, concept generation, and deliverable 7, material choice. Now, the findings in both of those were useful. However, engineering, as we all know, is iterative. So, as we progress forward, it's a wonderful stepping stone. However, obviously, things will likely change from these documents. Tax ahead. So, today, engineering ethics is due, and deliverable 8 will be due next Monday. As you can see along our Gantt chart, even though it's a little blurry. See Monday 16th, and then today for ethics. So going into our design evolution, for the modeling section of this next deliverable, what we're looking at particularly is a design change which we made last week. Now you can see on this left image that the main casing housing is below the dashboard. However, within the past week, we have decided to move it above the dash, and this is for a multitude of reasons, but mostly due to the complexity of the electronics and different air conditioning vents and whatnot that lie below the dash. We didn't want to take apart someone's dash and then find out that we didn't have enough space. So for the sake of simplicity as well as universality, if we were going to attach this to a different vehicle other than our base model, which is a late model Chevy GMC 1500 truck, we found that it would be easier to mount it on top. And with this, the safety measures need to be looked at in regards to becoming a projectile. Now, putting the casing on top, we increase the risk of, during an impact, the device coming loose from its moorings and becoming a projectile within the cabin. And so with this, we're taking different modeling approaches, such as checking the bolt patterns, different ways of adhering the casing to the dashboard itself, what kind of forces are going to be exerted during a regular crash on this device, as well as the upper pulleys, how we're going to be mounting those to the A-pillars, and if not the A-pillars, the windshield itself. Another part of our modeling process that we're looking towards is what forces are going to be exerted on the drivetrain, on the axle. There are obviously constant torques that will come from operation of the pulley and the pinwheels and whatnot. However, we need to analyze exactly what kind of friction could be felt within the bearings that just support the axle and just hold it in place. You can see this kind of imaged here on the left as I'm circling it with my cursor. But as we go along, we're using what we learned from our materials selection in regards to our pulley chain is going to be made of Delrin plastic, as well as plastic being used for our pulleys. And our DC motor, all these pulleys in the motor will be coming from an RC component website. And the reason for this decision relies mainly on the fact that it's cheap, but also they provide a lot of specifications that will make our analysis next semester a lot easier. So today I cover tasks completed, tasks ahead, and some of our design evolution. Thank you for watching. Have a wonderful day.